All right. So I'm VJ from HackBuddy. It's been a while, and we haven't had many meetups in almost a year now. And so I wanted to get that going again. And tonight we have Colin Ihrig, and he's doing Node.js. And so we wanted to have a presentation on Node.js Test Runner, just kind of see, as a kind of like to kickstart 2025, what's changed, what's interesting about test runners and Node.js, and just really bring back some attention around JavaScript for the community and get this going. The whole idea here is to help make people watching this a better software engineer, have the better toolkit for their engineering chops, and we want to just help you all become more leveled up. So that's my role. That's what I do. I'm an organizer, and I make sure that people, including myself, get a lot of benefit out of this. So I want to thank you for your time, Colin, and just being with us tonight. And I see that you have the presentation already, so I'm going to hand it over to you.
Okay, awesome. Thank you for having me. So yeah, my name is Colin Ihrig. I'm a software engineer at Joint. I am the original author of the Node.js test runner. Still working on maintaining and improving it. So I wanted to kind of give an in-depth talk about it tonight. To kind of go over things that may have evolved since it was originally released nearly 3 years ago. Maybe clear up some misconceptions. I've seen blog posts where people say things that uh, just aren't true or are in the documents. So I wanted to clear those things up. So with that, let's go ahead and jump in. So I guess let's start with why Node needed a test runner in the first place. So in the bottom corner here, I have a tweet that I had sent out September of 2021. At this point, I was using a test runner called Lab, and the most recent update, it had integrated ESLint, and the most updated version of it like broke, and ESLint didn't work, and I was trying to fix it, and I got mad and said, Node should just have a test runner. And so like my reasoning for that was, first off, most projects need a test runner. So, everyone writes one-off scripts that they throw away and things like that and hobby projects. But if you're doing anything serious, you probably do need like actual tests. Um, and Node already had an assertion library, Node assert. So I think it's a good assertion library. I know a lot of people may disagree with that, but I actually enjoy it. If you don't enjoy it, that's fine. You actually don't need to use Node's assertion library, and I'll show you a little bit more about that later. Um, and then, Node already had, or JavaScript in general, had a fairly large ecosystem of test runners to begin with. There was Lab, like I mentioned, Mocha, which had been around for a long time, Jest. I don't remember if VTest existed back at this point or not, but there were a number of other ones. But my main kind of problem with all these test runners is that they're a very large dependency. So, often on the order of megabytes. A lot of them do things that I don't really agree with, like injecting globals into your environment. And some of them are focused on the browser, whereas I'm my development is on Node.js, so like I wanted something that was kind of more tuned to Node.js. Um, and then just my kind of development outlook in general is that NPM is a dangerous place. So, I'm sure people have heard about like LeftPad and Colors.js, and the list goes on and on of like NPM packages that have had problems and have either been hacked or intentionally broken, and have broken hundreds, thousands of different builds. So I try to avoid relying on npm when possible. Obviously, for something like a framework or something like that, it's okay to use npm. But these test runners are really large. They have a lot of dependencies, and so I was kind of hoping to avoid that. And so with that, we kind of went on this journey to create a test runner for Node. And originally, the idea was we should have a test runner. It should be very, very, very simple. Maybe a test function and one or two other things. Um, And originally, everyone wanted TAP output, which stands for Test Anything Protocol. It's an output format for test runners. And this was kind of the idea of people inside of Node Core. Once it kind of escaped into the wild, the larger JavaScript ecosystem was like, we want more than that. So it's kind of evolved over the years from just a very basic, test function that can output TAP. So if you wanted to get started with the Node test runner, the first place you would look is the Node test module. This is a core module, so just like FS, HTTP, any of those modules that you would import from Node Core. It's been available since Node 18, which launched in April of 2022. It was experimental, as most Node.js features are when they first come out. We stabilized it a year later for V20 in April 2023. And as of today, it's now December 2024. Node V24 will be out in April of 2025. And a good bit of things have changed in the test runner since then. So one thing that you'll note if you ever try to use Node test is that it has to be imported with the Node colon scheme. Um, so any of the Node core modules can be imported like this, but Node test was kind of the first, and I think moving forward, it's the pattern that Node core will follow, where you have to use this Node prefix. So if you just write, import test or require test, you're actually going to try to look something up in your Node modules directory, which is probably not what you're actually looking for. So that's one thing to keep in mind. Another thing about the design of Node test is that each test file is just a normal Node.js program. So just like you would run, Node foo.js or mjs or whatever TS, you can run any of your test files this way. So that's really nice whenever you're trying to debug like one specific file. You don't have to run your entire suite. So you just run node test.js. There's also not any type of magical testing environment. So I had mentioned in the previous slide that was something that kind of bugged me about some of the other popular test runners. There's not going to be any globals that are injected for you. You would require everything from Node test. The test runner doesn't perform any source code modifications, so it's not going to rewrite your source code for snapshots. It's not going to hoist things up, kind of without you knowing. And this is nice because we try to make it as close to the environment where your test would or where your code would actually be running as possible. And so, whenever your test runner does all these things, you think your tests are running fine, and then you go to run it in an actual environment, and you quickly realize that that's not the case. So if you wanted to actually write tests, this is what it would look like. Again, I've imported node assert here to do some assertions. You don't have to use node assert. Anything that throws is considered a failing test. Anything that passes or anything that doesn't throw is a passing test. You can also return promises. So you can use an async function, or you can return a promise directly. If that promise is rejected, that will count as a failure as well. So here we import the test function from node test. We have a synchronous test here where it's just a normal arrow function. You can use the function keyword if you want. You don't have to use arrow functions. We have a simple assertion here, asserting that 1 is in fact equal to 1. And then we have a failing test down below. We're using an async function here, asserting that 1 is equal to 2. That is obviously not true. So that is going to be a failure. So another kind of thing that you can do is use callbacks. So this is not quite as popular as it used to be, but originally Node was like all callbacks everywhere all the time. And so the way that you would use callbacks is when you write your test function, you would just pass it two parameters. So here it's t and done. I'll talk about t on the next slide. Done is your callback function. So just like any other test, you can throw or reject from here and it'll count as a failure. But you can also call this done. And if you call it with no parameters, it will pass. If you call it with a parameter, it'll treat that parameter as an error. And so the test would fail. The other thing worth pointing out here is that I used it instead of test. So I know a lot of people are fans of like describe and it, which is popular with like Mocha and I think in Jest as well. So they're just aliases for one another. So you can use test or it interchangeably. So the way this test works is it will run, it sets a timeout that will trigger after 1 second. After that 1 second passes, we have a simple assertion here that's going to pass, and then we call done, and the test will be considered done. If you never did call done here, the test would just kind of hang and time out eventually. So on the previous slide, I mentioned T. That is your actual test context. So it's an object that gets passed to every test. And each test gets their own unique context. And this is going to contain things like assertions. So I mentioned before, Node, you can use Node's assertion library or not use Node's assertion library. Um, but we also create a bunch of assertion functions based on Node assert on each context. Um, I'll get back to why that is in a second. The context is also where we handle snapshot testing that I'll talk about later, test plans, and various other things. So what would something like that look like? So again, I have an example test here. T is the test context. I do t.diagnostic. So this is a way of doing outputting a message that will basically be attached to your test. So you can use something like console log or console error or anything you want really to print something. But that is kind of like here's console log and here's the test runner, and they work together, but they're not like there's no type of binding there. T.diagnostic actually gives you that binding. So this print statement here will actually come out with the test, and it'll be wherever that test is, it will be tied to that. And you can see it's a template string here where we use t.fullname. So that will give you the full name of the test. In this case, it's a test using its context. If it was nested inside of other tests or inside of suites, the full name would actually include all of those separated by the little angle bracket. So you can see kind of what your test is that you're working with. So the next thing is t.plan. So if you've ever used test plans before, they're really helpful if you have like a bunch of asynchronous code and you're not really sure if things are going to execute or not. So in this example, it's kind of contrived, but t.plan2 says I'm making an assertion that my test is going to make two more assertions. And so if the test finishes and I have, less than two or greater than two assertions, then the test will actually fail saying your test plan was incorrect. Um, and so then below that, we have t.assert. So these are the same methods that you can get off of Node's assertion library. So deep strict equal and strict equal, they're just aliases for the same functions in Node assert. But you have to use t.assert if you want to use the test plan, because it's kind of like I mentioned with the console log. It's like Node's assertion library will work, and the test plan will work, but they don't know about each other. So by introducing this t.assert, we were able to make the assertions more context aware. And so like a lot of projects, I know Fastify is a big user of test plans. So that's basically how your test context would work. So next I wanted to talk about nesting tests. So you can nest tests as arbitrarily as you'd like to. The one kind of caveat here is that if you put a test inside of another test, the parent test does not wait for the children to finish. So test returns a promise, so you would await the test here. And so, this will basically in your output, you'll see a test with subtests, and then you'll see some indentation, and then you'll see nested test, and then you'll see a subtest. And there's two different ways that you can write these tests. You'll see the first one uses the global test function, so you don't have to do anything, fancy there. The other one, it uses t.test, so there's actually a test function on your test context. The reason is originally when the test runner was designed, the idea was that we were going to use t.test. People wanted to be able to just reuse the same test function over, so we added that functionality in as well. So the next thing I'm going to talk about are suites. So suites are different from tests. A suite is kind of a container for one or more tests. They behave a little bit differently. So they actually do wait for their children to finish. So in this case, you'll see that there's no awaits anywhere in the code. If you don't want to have to await any of your children, I suggest using this format. Um, Again, we have sweet and describe. They're just aliases for one another. So whichever kind of testing terminology you prefer to use, they're both there. You can use sweet and test, or use sweet and it, describe and test. Like you can mix and match them any way you want. And yeah, that's the basics on suites. I did want to say, one note on the return promises is that, like I said, you do have to await your tests inside of other tests. Otherwise, an unfinished test will be canceled, and you'll see it counted as a failure. And I believe the message will say something about did not finish before its parent or something like that, and was canceled. So it'll tell you why, but if you're wondering how to fix it, that's exactly how. And another note is you never need to do this. I know that there was at least one linter that would complain about floating promises. They have since, I think, rectified that, so you don't even have to do that to appease your linter anymore. You don't have to await suites ever. You don't have to await tests inside of suites. I've also seen people use void there instead of await. It returns a promise. You don't have to use it. The only time you have to use it is if you have a test inside of another test. We also support test hooks. So if you've used any, I think all of the major testing frameworks support these, before each, after, and after each. These are just additional functions that run at various point in the test lifecycle. It's really useful if you want to set something up and then tear something down. And the problem that they solve is, before my test, I might want to start a server or create some file or do something else, and then my test runs. But if my test were to fail, because an exception is thrown, then my cleanup code might not ever run. So I can set up an after hook. So I create my server or file or whatever, and then I immediately create an after hook. And when the test runs, that after hook will perform the cleanup, whether the test failed or not. And then the difference with the each variance is, if you're, say you're writing a suite, the before will run before you execute any of the tests in the suite. Before each will execute before every test in the suite. Similarly, after each will execute after each test in the suite, and after will execute after the suite is done executing itself. So you can also skip tests. So we have two ways of doing this. So you can either pass an options argument with skip set to true as the second parameter to test, or you can do test.skip right up front. So I personally prefer the first variation because it lets you do things like put logic there. So say for example, I'm running on Windows and my application only runs, this part of my application only runs on Linux or Mac. You can actually have like an is Windows variable, and you can use that for your skip condition, and that way the test will automatically not run on Windows instead of having to like go in and skip every single one, or put any type of additional checking in there. Um, so the way that skip tests work, they do still show up in the output, but they're marked as skipped. So I'll show you in a little bit later. There are other types of tests that just don't run at all. It's like they never existed. But because skipping tests is usually done for a small handful of tests, it's useful to still include those in the output. We also support something called to-do tests. So this is kind of an artifact left over from when we were only working with tap, because this is something that I know comes from the tap protocol, but it's actually useful outside of that context as well. It basically indicates that you have a test that is either expected to fail or still kind of incomplete. And you run this the same way you would do skip. So you either pass an option to do set to true, or you can do test.todo. And so in this case, both of these tests will execute. Both of them will fail because they throw an error, but it won't fail your test suite. So you'll still exit with the process will still end with an exit code of 0. It'll still report success, but the test itself won't actually pass. Then next, I wanted to talk about only tests. So these are kind of, I mentioned when I was talking about skip tests, these are different in the fact that this is filtering. and these tests won't show up in the output at all. So originally, back in like Node 18, I can't remember if we fixed it in Node 20 or not, um, only tests were treated as skip tests. The problem with that is only tests, you usually will apply it to like one or two tests out of your entire test suite. And so, say you have 500 tests and you only want to run one, it's useful to only see the one that you're running. You don't want to see, 499 output lines of skip tests. So only tests, you do it the same way as skip and to do. There's the only option or dot only on the test function. And these are the only ones that will actually run. One kind of caveat here is that if you're using process isolation, which means that each test file runs in its own individual process, then you have to pass the dash dash test only flag. The reason for that is when you start the test suite up, you basically have to walk all of the test suite, discover all of the suites and tests that you're going to execute, then see if any of them were marked as only. And if that's the case, then you would filter out all of the ones that don't have the only flag. If you're running all of your test files as different processes, then it's either going to be really slow, or you have to have some type of control logic where basically you spawn these child processes. They all would have to then run and detect if there was an only test, report it back to the main orchestration test runner process, and then kind of apply the filtering after that. So I think Node Tap, which is another test runner, I think they have something similar because they also use process level isolation. If you're not using process level isolation, so something like the way Mocha works out of the box, then you don't need to do this. If you're running a single test file by itself, like Node test.js, then you also don't need to do this. But just kind of that was a caveat worth pointing out. So now that we talked about kind of the basics of the Node test module, I wanted to talk about the actual test runner CLI. So inside of Node, if you've ever used Node.js before, and I'm assuming that everyone here has, you've probably started Node with one or more flags. Dash dash test is how you would actually start the test runner. And what it does is by default, it will use process level isolation. It will discover all of your tests, whether it's by glob patterns that you provide, specific file names that you provide. If you only run dash dash test, I have the list of patterns that it will try to find on its own. It will run all of those files that it discovers, each in their own child process, and then it will gather the results back. They communicate over, I think, standard out back to the main test runner process. The test runner process will then combine all the results and give you an output. If you use dash dash test to run a single test file, with the exception of like very small edge cases, it should be the exact same output as if you were to run that test file directly. There are other ways to run your tests that don't use process level isolation. I'll talk about that later in the talk, but by default, this is how it works. So the test isolation that I was just talking about, again, it gives you a child process for each file. The processes run in parallel, which is nice because the work can execute faster. The tests can't interfere with each other at all. Um, the I guess one kind of issue there is that sometimes people want their tests to run all in the same process. Say they have some expensive startup code that they only want to pay the price for once. Also, sometimes it can just be a lot faster to disable process level isolation because there is the overhead of spawning child processes and gathering all the results back from those processes and combining them. So you can actually turn that off with experimental test isolation set to none. And that will give you something similar to how Mocha operates, for example. So it will discover all the same test files, but it will run them in the test runner process itself sequentially. So there's going to be less parallelism there. You can control parallelism at the individual test or suite level still. So if that's something important to you, it is still an option. It can, if you do that, it can be faster, but it can also lead to tests kind of stepping on each other's toes. So, if you have one test that writes a file and then another test expects that file not to be there because they're running in the same process, that can happen. But if you've used Mocha or anything like that, then you've come across this in the past as it is. So what I suggest is, you pick the isolation mode that works best for you. Um, different people have different choices. This is an experimental flag, but I will note that we're going to be enabling it by default soon. So, it hasn't changed since it's been introduced. So just because it's experimental, don't think that it's going to, suddenly break out from under you. I will say it's pretty safe to use. So the next kind of topic I want to touch on is what we call reporters. And this is basically how the test runner communicates to the outside world of what's happening. So we picked node streams as kind of the format and how reporters are structured because they have some nice properties. It's a common interface that a lot of people are familiar with from working with Node, but you can also do things like pipe them together. So you get your test runner output stream, and you can set up multiple reporters. So you could have one reporter writing tap output to standard out, and you could have another reporter that's taking coverage data and code coverage and dumping that into a file. And these all work nicely together because of how streams work in Node. So like I said, it is just a stream. You can combine multiple reporters and destinations together. So that was the example I gave, sending something to standard out, something to a file. We have a number of them built into core. So spec as of node 23 is always the default. Spec just means it's kind of more human readable. It has nice colors and things like that. TAP was the old default. Test anything protocol. It's a little more verbose. It's generally good for running in the CI or sending it to other tools because it's a well-defined format. It has a specification. It's been around for a long time. So there are tools that support it, know how to take your TAP results and format them nicely. We also have the dot reporter, which is kind of uh, I would say the least verbose out of all the reporters that we have built in. So it basically gives you a dot, it'll do dot, 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 dot across the line for each test that passes. And then you'll get a red X if the test fails. And then at the very end, you get a summary. We support JUnit XML. And then we have LCOV, which is a coverage format. So this will not actually output any test results for you, but it will pick up coverage data and dump that for you. And then users can also define their own because it is just a Node.js stream. You just have to consume that stream. We have all of the events that you have to handle are documented on the website and the docs. We have examples of how to do it. One of the other contributors to the test runner has a whole at reporters scope on npm where they've created a bunch of different test reporters. So I'll show one of them later in the presentation. But they have, for example, you can make it look like Mocha if you really like the way Mocha looks. You can use GitHub annotations. So you run it in the CI, and if there's problems, it will actually annotate your CI run with the errors and stuff. It's pretty cool. So this is an example of what the reporters themselves kind of output. On the left is tap. You'll see here, there's no coloring. It's kind of designed for machines. It's not the most readable thing. Whereas on the right, we have the spec reporter, which is the default that we want to show people. So, passing tests have green, failing tests come out with red, and then have the error that occurred. For both reporters, we have a little summary at the end talking about how many tests were run, suites, how many passed, failed, that type of thing. We also have the duration there. So that is the duration as close as possible from when the test process, like the test runner started until it finished. I know some test runners kind of fudge this number a little bit and they'll take like a sum of how long each individual test took. This was going to be closer to like what your end user would actually experience though. Then at the very end, we print again a listing of all the tests that failed. so that you don't have to scroll back up and try to find things in the output. And you'll see here that we include the location of the test. So you'll see here test at test.mjs line 7 column 1. The stack trace of the error itself. So the test was located at line 7. The error was thrown from line 8 though, and that type of thing. So we also support mocking out of the box. The mocking functionality can be used entirely separate from the test runner. It's entirely separate from node test. So you would still import it from the node test module, but it won't bootstrap the test runner itself until you actually like define your first test. So say you wanted to use Mocha or Jest or whatever, but you wanted to be able to use mocking from node core, that's totally supported. Um, we support mocking functions, so you can create a spy. It can give you back just a blank function that you can pass around, or you can actually pass an existing function in, and it will wrap that function, so you can kind of see how that function was invoked as you pass it around. We can mock methods. We have special code paths for getters and setters because they're kind of a little unique from functions and methods. We have mocking for dates and timers. I will say that's the one part of the test runner that I have not worked on personally myself at all, but I hear that it's nice. We also support mocking CommonJS and ES modules. So this is kind of a big deal because ES modules are notoriously difficult to mock. Uh, CommonJS was easy because we have this require function, we have the require cache. Anybody can tamper with the require cache, so that's what people have done historically. But ESM, it's actually part of the spec that you can't really get at that module cache. So we waited until loaders, which are a way to kind of customize how ES modules are loaded inside of Node. We waited until those were created, and then we built this mocking functionality on top of that. Um, Mocking of modules is still experimental because the loaders that they're built on top of are also still experimental. Once those are stabilized, we'll stabilize the mocking as well. I mentioned before you can mock globally without using node test, or you can actually mock in a specific test context itself, and I'll show you that on the next slide. The thing that's nice about that is if you do it inside of the context, you don't have to worry about restoring your mocks. So say I were to mock, array.prototype.push, and I forget to restore it, and then my next test runs and it relies on that function, it's going to pick up the global mock. Whereas if I do it at the context level, it'll be restored by the time we move on to the next test, and you kind of get a clean slate to work with. So this is what that would look like. So if you wanted to use the global one, you would just import mock from node test. If you want to use the context one, you use t.mock. Other than that, the APIs are the exact same. So in this case, we're mocking a function that adds two variables together. It'll return the mock function in a variable called sum. And then you can see we can perform assertions on that. So if I do sum 3 and 4, we would expect the result to be 7, which it is. But then there's also a mock property on the return function where we can kind of inspect how the function was used. So for example, here we're using call count. We can actually see how many times this mock function was called. Because we've only called it once here, that value is going to be 1. Then you can get at each individual call as well. So here I have const call. I'm getting sum.mock call sub 0. That's going to be the first time the mock was called. And then you can see what the arguments were. In this case, it was the numbers 3 and 4. You can see what the result is. There's a variety of other things you can check here. So like you can see if an error was thrown and things like that. All that's available in the documentation. So next is snapshot testing. I think snapshot testing was popularized by Jest. I know just about every test runner supports it at this point. The way it works is you serialize known good values into a snapshot file. And this is useful if you're wanting to, for example, render some entire HTML page, or on the back end, if you're trying to render, I use this a lot for CloudFormation templates when I worked at AWS. Um, these large things you don't want to necessarily include the assertions for in your source code. And the way it works is in our case, by default, we will stringify whatever your value is using JSON.stringify. So that's great because JSON stringify is available everywhere. It's a good default. It does have limitations. So, for example, you can't stringify an object that is circular. We did provide additional APIs where you can configure the serialization as well as the snapshot file. And you can do this on a per test, or I'm sorry, per snapshot basis, or you can do it at the process level. So I have an example later on in this presentation where I'll show you where we can basically take node snapshot testing and make it behave exactly the same way that Jest would. The way you would use this is you use the t.assert because snapshots are not something that Node's assertion module supports. You do have to use t.assert. It's custom to the test runner there. You just pass in the value that you want to assert on, and the first time through it'll fail because it'll look up that snapshot and it won't exist. So you start Node with the --test update snapshots flag, and it will generate your snapshots for you. And then from there, you're able to run it. The assertions will pass unless something has changed, in which case it will fail, and that's what you want to have happen. The test runner also has experimental code coverage support. So this uses V8's built-in code coverage. So V8 has kind of I would say code coverage that's kind of rough around the edges compared to something like Istanbul. And then prior to the test runner existing, Node already had a mechanism for exporting code coverage files. The test runner takes that another step further and actually takes those output files and combines them into a human readable report. And so we can give you, on a per file basis, we can give you metrics on, what percentage of your lines were covered, branches, functions. I know statements is the other big one that a lot of coverage tools have. V8 does not do that. So we don't have statement coverage. I believe C8 doesn't do that, and C8 is kind of like the de facto standard for how coverage is done at this point. We do have support for source maps. So if you want to use TypeScript or CoffeeScript or whatever you're transpiling, you can get back your original error locations and whatnot. You can access the coverage information programmatically. So the reporter that I mentioned before, which is just a Node.js stream, it does have a test coverage event that it will emit if coverage is enabled. And so you can tie into that programmatically if you want to. And all of this is enabled via the -- experimental test coverage flag. And then if you have coverage enabled, you're also able to set coverage thresholds. So this is useful for, if people are fans of 100% code coverage. It doesn't necessarily have to be 100. It's nice that you have, say half of your code is covered. You could do like -- test coverage lines equals 50, and that'll say, 50% of your code, 50% of the lines are executed. We have similar flags for branches and functions, although I think lines are probably the most popular one. And so, if say all of your tests pass, but your threshold or your coverage has slipped below that threshold, then, you'll get a failure and you'll get output that'll kind of explain why. And so this is what it would look like. So we have, just a basic test here. You can see the summary. We had one test that ran. It passed. However, in our code, we only covered 78.35% of the lines, and we had started this with a threshold of 99%. So you see the coverage report here. It shows you kind of, percentages of lines as well as specifically which lines were not covered. And so you can kind of see, why your test failed and where you need to add coverage. So I know a lot of people are not fans of code coverage. They say it's kind of a fake metric. I personally like code coverage. I'm not someone who obsesses over it, but it's kind of good to know. With a language like JavaScript, if a line is not executed, you kind of don't really know what might be happening in that line because you don't have the compiler there. So I think it's a useful thing to have built into the test runner. We also support watch mode. So a couple versions ago, Node.js in general got support for watch mode with the dash dash watch flag. And it's kind of like NodeMon. So if you're writing your writing your code and you change your input files, um, Node is watching those and it'll restart your process for you. The test runner is the same way. It does have first class support for the watch flag. So if you're writing your tests and you change your input or you change a test file, it'll automatically rerun those for you whenever you save. All you have to do is add dash dash watch onto the end of your whatever CLI command you gave it. So this is a big one. Recently, Node.js got support for stripping types. I think there's another flag there as well that can kind of convert TypeScript syntax into JavaScript if it's not supported. But the big one is experimental strip types. And so the way it works is, say you have a TypeScript file. Before running, it will actually rip out all of the type information, and you'll just be left with plain JavaScript. And then it'll execute that like nothing happened. When this flag is provided to Node, it will actually then add TypeScript files to the globs that it will search for. So you can write your code directly with .ts extension, and if you run Node with the experimental strip types flag, then the test runner will just pick it up for you automatically. If you're using an older version of Node that supports the test runner but doesn't have this experimental strip types, you can use something like TSX. TSX does support the dash dash test flag. And then there are other flags that, or I'm sorry, other tools that do similar things. Borp is another one that kind of wraps the Node test runner to make it a little more user friendly, for example. So some of the other features that we have, dash dash test concurrency. This is how you can tell the CLI how many files to run in parallel. So by default, if you're using process level isolation, it will look at how many, like what the available parallelism is on your machine. So it actually calls the os.available parallelism method. Um, you can think of it as, say I have 8 cores on my machine. I want to have 1 core dedicated to the test runner and spawn 7 child processes to run my test files. You can override that though with the test concurrency flag. There's also the dash dash test force exit flag. It does exactly what the name says. It forces an exit after all the tests have run. A lot of people like to use this flag for things like if I'm being honest, it's because they're being lazy. They have a server and there might be some handles or something else keeping the node process alive. Instead of trying to figure out why that is and cleaning up after themselves, they just pass this flag and the test runner will force the process to exit for you. Whereas otherwise it would just kind of sit there waiting for you to clean up after yourself. There's also the test name pattern. So this is useful for running. It's similar. It behaves similarly to the only flag, whereas you can do filtering, but this allows you to pass in a regular expression. So say I want to run the test foo, and I have 20 different tests, and it'll run whichever ones match that pattern. Kind of the inverse of that is the test skip pattern. So instead of running those tests, it'll actually skip those tests. There's also a flag called test shards. And this one, sorry, test shards will actually take your entire test suite and it'll split it up. So say I want to split it up into 4 pieces across different. It's useful for running across different machines or things like that in the CI. If I run dash 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 test shard equals 1/4, then it'll split my test suite up into 4 chunks and it'll run the first one. Similarly, if I did 2/4, it would run the second chunk out of 4. It's not like if I do 2/4, it's not like a fraction where it's going to say it reduces to running half of it. It's for running isolated chunks of your test suite. And then I wasn't really sure where to include this. I didn't think it really deserved its own slide, but we do leverage something in the test runner called primordials. So what this does is it makes the test runner more resistant to tampering. And so what does this mean? Say I want to go in and monkey patch something, regardless of whether I'm using mocking or what. Say I just at the very top of my file, I require the test runner, and then I do array.prototype.push equals a new function. If you run that in Mocha, you'll the file will run. It'll say there were 0 tests because Mocha does not know how to handle the fact that you broke array.prototype.push. Inside of Node Core, we try to make certain parts of the runtime more resistant to that type of tampering. The test runner is a big one for that because we have to run all these different types of code where people are doing things that may not even be the right thing to do, and so we don't want the test runner to just kind of break down if someone passes in bad code. And so that is something that I think is kind of a lesser known but still really nice feature of the test runner is that you can try to break the code and hopefully the test runner won't go down with it. So now I wanted to get into why you should or should not kind of use the Node test runner. So I wanted to start off with the limitations because I'm not going to sit here and pretend that it's this perfect piece of software. Nothing is. Um, you know, a lot of the limitations of the test runner come from the fact that it is built into core. So it's never going to have as many, bells and whistles as some of the user land alternatives. So a good example of this is like the snapshot testing. Yes, we do support snapshot testing. If you look at Jest and VTest, they have like snapshots, inline snapshots, file-based snapshots where they don't escape anything. Like there's all these different types of snapshots that realistically, we may accumulate some over time in node tests, but we'll probably never have all of those features. Just in the same way that Node's HTTP module doesn't have all of the bells and whistles of a framework like Express or Fastify or one of those. That's just the nature of it being built into core. The other thing is that it is tied to Node Core's release schedule. So it's a predictable schedule. There's an LTS schedule. Things are Node 18, which came out in April of 2022, is still supported. It doesn't go end of life until I believe next April. So like these releases have to live for a long time. Once things hit LTS, features don't necessarily get backported. So that is something you have to think about. Like if you're relying on a brand new feature, but you also have to support back to Node 18, it's not going to happen for you. Another thing is that the test runner does target Node.js specifically, so it's focused on things that Node can do. It's not a browser; it doesn't pretend to be a browser. There are other test frameworks out there that are more suited for testing interactive web pages and things of that nature. The goal here was to try to make the best runner for Node.js specific code, and that's kind of still the goal. And then kind of a more smaller but annoying thing is that the CLI flags are verbose and namespaced. So as you see here, all of them start with dash dash test and then whatever. Again, the reason is because it's built into core. So while it might be nice to have dash skip. Um, in the context of Node Core, people would not really be sure what's that referring to. Is that skip an HTTP request? Is that skip something else? So we kind of had to make these more verbose flags. Again, there's a number of projects in the ecosystem that have actually wrapped the Node test runner to still leverage it, but to make it a little more user friendly. The other thing is those CLI flags are Node core flags. They are not application flags. So this can impact things like if you're trying to do test name filtering specifically. Say I run npm test dash dash test name pattern or whatever. Um, that because it's an npm script, that test name pattern is going to be passed to the application, not to Node.js itself. So that's kind of a known limitation. There are different ways to work around it, whether it's wrapping it yourself or it could be solved in Node Core. There's an issue for it where we've kind of discussed it, but I feel like it may lead to more confusion if we were to try to implement that. But it's there if anyone else wants to try to implement it. So then onto the good things. I went out looking for kind of benchmarks that may have already existed for the test runner, and I found this other test runner called Poku. I hope I'm pronouncing it right. And the idea is it's supposed to be a test runner that works across all of the different runtimes, so like Dino and Bun and all of that. Um, and they force isolation, like test process level isolation. So they run their own framework. They compare it to like the core framework, but they also compare it to some of these userland frameworks. And their results are easy to read, but not I don't know, not my favorite in terms of like benchmarks. But it does say that Poku is faster than all of these userland alternatives and slower than Node Core. So I was like, that's promising. Um, but like for example, I mentioned it forces all of them to use isolation. Mocha specifically does not use isolation by default. So I kind of wanted to come up with some benchmarks that I could kind of control myself and run. And so I did that. The repo is linked here at the bottom of the slide. And I focused specifically on comparing Node test with Mocha because Mocha is generally the fastest of the major testing frameworks outside of core. And so what I did was I compared node test with process level isolation, node test with no isolation, and then the same configurations for Mocha. And so what you'll see here, the bars are just execution time in nanoseconds, so lower is better. Uh, the two on the left, the blue and the green, are what I'm hoping are going to be the lowest. And then the benchmark names here, 1F and 10F stand for the number of test files that there are. And then the 10 or 1000 or 100 TPF is tests per file. So on the far left here, we have one file that only contains 10 tests. And on the far right, we have 10 files and each one contains 1,000 tests. So we're basically running a test suite of 10,000 tests. There aren't a lot of applications that I've seen out there that have 10,000 tests. So I think this is a kind of an accurate representation. But what we can see across the board is that node test without any type of isolation is the fastest. Um, and node test with process isolation is a little slower, but still comparable to Mocha. Um, and this is not any type of like targeting of Mocha. Mocha is actually after node test my favorite testing framework. So I just was trying to look for the kind of most competitive thing to compare against. The other reason why I would want to use the node test framework is because of supply chain security. So I touched on this at the beginning of the talk. If you've ever used, if you were around whenever LeftPad was a thing or when the Colors JS debacle happened, this one in particular was from Colors JS, and the author I think was mad because companies were using his stuff without giving him any type of compensation. So he intentionally broke his own Colors JS module that was very popular. And you can see this screenshot here is from running the CDK, which is actually an AWS tool. So this happened while I was at AWS. It was like 2020 or 2021. But it broke a lot of people. And so while this is not specifically tied to a test framework, it is kind of illustrating, why you may want to avoid things like like npm packages to as much as it makes reasonable sense to do so. So comparing it to some of the other popular frameworks out there, I looked at the additional installation size that each of these comes with. Obviously, node test is not 0 bytes. The code itself does actually use space, but it's already in the binary and it's part of what you're already running. So there's no additional size here. Um, and the first line here is 17.5 MB. And while Ava and Mocha are able to come in below that, they're each still, a number of megabytes, and that's repeated across, every project you have, unless you're installing these things globally. And so in my own personal opinion, that's a lot of megabytes of code to install just to be able to run tests. And so what actually comes down in all these megabytes of code is hundreds of dependencies. So again, Node test has 0 external dependencies. It's all built into core. Mocha has a little over 100 and Mocha's on the smaller side. VTest does pretty well here. I don't remember what the exact number is, and I don't know the nature of all of their dependencies, but hundreds of dependencies is still something that, just to run tests, if I can avoid it, I would like to. And then I wanted to talk a little bit about how the test runner has kind of integrated into the ecosystem so far. So I went over all of these different components that exist and mentioned how they work together, but I also mentioned that you can use them separately. So you can use the node test module without using the test runner. You can use the node test module with other test runners if they know how to interpret its output. The assertion library, I like node assert. A lot of people like chai. A lot of people like expect from Jest and things like that. So like the assertion library has to be plug and play. Same thing with the mocking library. If you want to use sign-in, you can. If you want to use the mocking framework here with some other test runner, you can definitely do that as well. The test runner CLI, again, you can run node dash dash test. You can run it on a regular script because it just looks at the process exit code. So you don't even have to have tests in that file. You can run, you could run your Mocha tests and it's just going to look at the process exit code. So that's all fine. The snapshot serialization, like I mentioned before, JSON.stringify is not good enough for everything that you might want to serialize, but there's also not a protocol inside of Node itself that can be used reliably. There's something like util.inspect, which is what console log uses and whatnot, but that's not actually guaranteed. That's meant specifically in the documentation. That's meant for human debugging. That's not a format that you should rely on and can break between releases. So that's why we had to make sure that the serialization process was configurable. And then there's also a function that can be imported from Node test called run. I haven't talked about that at all yet. That is the programmatic API for running the test runner. It supports everything that the test runner supports because the test runner is actually built on top of run. So whenever you run node dash dash test, it gathers up, all the configuration and options and it calls run. Run is, there's different projects out in the ecosystem that are wrapping node test specifically by using the run API. And so what do some of these integrations look like? I mentioned BORP before. BORP actually will transpile TypeScript. This was before TypeScript integration existed in core. It transpiles your TypeScript one time and then calls the run function. So it's pretty performant. There's TSX, better node tests, all these other tools out there that wrap node test. I mentioned the @reporters scope on NPM. GitHub reporter, different things for like bailing out if you want to have your reporter exit after the first failure and things like that. There are integrations into some popular tools. So like VS Code has a node test extension. It's pretty nice. It's maintained by somebody from Microsoft, so it's kind of a first-class citizen. WebStorm, I don't use WebStorm myself, but I know that it has node test integration. Another product is called Wallaby. I haven't used that one either, but I know they have node test integration. I mentioned how node test and the CLI can be used interchangeably with other frameworks. Node Tap, which is another framework, they have actually implemented this. So they can use their CLI to run node test files, and they can have their files output a format that the Node.js CLI can understand. So that kind of interoperability is pretty cool. I know Cloudflare Workers, which is a runtime from Cloudflare, they've actually implemented the Node mock API. I think everything except for the module mocking. And I know Dino has some minimal support for node test in their node compatibility layer. I'm not sure if Bun is planning to add it. I know I saw a pull request to Bun recently for specifically running Node.js tests. I don't know what their plans are there though. And so I've been telling people on Twitter since the test runner came out that you could actually basically combine all these pieces together. And still, I would always see people saying that it wasn't possible. So I actually put together an example repo that does just that. So you can see your test file over here on the left. We're using the node test, but we're using chai as the assertion library. So you can see all of the expect assertions that people love. And then I have a snapshot test at the very bottom, and you can see I'm snapshotting a circular data structure, which is not supported by JSON stringify. On the right-hand side, I have a preloaded file that gets run with the test runner that basically configures it to work like Jest. So it uses pretty format, which as far as I know is the serializer that Jest uses for its snapshots. And then we call snapshot.set default snapshot serializers, which takes an array. So we want it to use the format function from pretty format. And then node test and Jest actually store their snapshot files in different locations. So this set resolver or set resolve snapshot path will actually it's an API that we provided that can be used to customize where the snapshot file itself is saved. So whenever you run this now, you should get an output that is snapshot files that are similar to Jest. And so what does this look like in the CI? So you see here, I'm using the Mocha reporter. That's this dash dash test reporter equals reporters slash Mocha. So you'll see the output here looks, if you're familiar with Mocha, you'll see that it looks very similar to Mocha. It looks nothing like the node test reporters. Experimental test snapshots. This is now stable. You don't need this flag anymore, but it is still supported. Import setup.mjs. That's this file on the right. So whenever you run each child process will run this before it actually starts up. So you can think of it as kind of a before each for each file. And then at the time, like I said, snapshots were experimental. They're no longer experimental, so this can actually be dropped now. And yeah, this is what the output looks like. So it looks like Mocha. It uses chai for assertions, and it does snapshots like Jest. So just kind of how you can configure all these different pieces to work together. And then the last thing I wanted to show was just I went on GitHub, searched through a bunch of public repositories, found a bunch of projects of various sizes that were using the test runner for their tests. Not necessarily for everything that they're doing. So you'll see .NET on here. Obviously, .NET is not using the node test runner for all of its stuff, but it had some like website builder or something where it was using it. Fastify is a very popular framework. Undici is a very popular HTTP client. It's how Node's fetch implementation is built. They're using it for their tests. Some big companies are using it. I just actually found out recently that Chrome, is it Web Vitals or something like that, was using it for their tests. So yeah, all of these companies and big projects are using it. So that's kind of my way of saying that I think that it's ready for production use. It's battle tested at this point, and it's been around for a few years. And that is everything that I had. I have a link here to the Node.js documentation for the test runner. If you want to reach me, that's my handle on GitHub and Twitter. And yeah, thank you for having me.